actually our second session of third day. Our speaker for the second day, Dr. R. Kousik Kumaar sir. He is from the Department of Aeronautical Engineering, NITTE. It's a deemed to be university in Bengaluru, because Bengaluru is known for actually aircrafts also. Like Chennai, it's actually Chennai is actually, I think many of you might have heard about it, actually the hub of automobile manufacturing units and plastic and rubber industries. Highest in actually Tamil Nadu, and Gujarat, and followed by Maharashtra compared to other states. This is just for information. Dr. R. Kousik Kumaar sir is a distinguished academician in aeronautical engineering from, basically he is from Coimbatore. He earned his BE and ME degrees in aeronautical engineering and followed by a PhD from the most popular university of Tamil Nadu, actually, that is Anna University. With over 11 years of teaching and research experience, he has worked at Nehru Institute of Engineering and Technology and is currently a faculty member of NITTE Meenakshi Institute of Technology, Bengaluru. His expertise lies in aircraft structural mechanics, composite materials, material characteristics, material characterizations, and CFD analysis. He has authored 4 books and 2 book chapters, and they are very young age. He's already published 15 journal papers and 23 conference papers. And he secured also 5 design patents and served on editorial board and as a reviewer of many journals. He is a life member of professional bodies like the Aeronautical Society of India, Institution of Engineers India, and was recognized among the top 50 expert faculties in India in the year 2019 by ULEX Academy. Dr. Kumar has also contributed to academic development through lectures, inspection, and coordination of seminars and workshops, participating in 60 plus FDPs and academic events. So I welcome sir, Dr. R. Kousik Kumaar sir, for this second half of today's program on behalf of Crescent University. So
thank you, sir.
Thanks. Yeah, you proceed, sir. Now it's yours.
Yeah, thank you. Thank you for your introduction, sir. And good evening to all the participants. And I'm Dr. R. Kousik Kumar from Department of Aeronautical Engineering, NITTE deemed to be University in Bangalore. And today I'm going to deliver the session on hybrid metal-polymer matrix composites, a new paradigm for multifunctional aerospace structures. So first, getting into this topic, first let us know why this topic will be working for us. So what is the need, what is the necessity for us to go into this topic? Because we had heard about metal matrix composite materials, we had heard about polymer matrix composites, but how could a metal and a polymer can be made as a composite materials? So that is called as hybrid metal matrix composite, metal polymer composite material. So how it works for us, what we should know from this. So the first thing is it bridges the expertise in MMCs with a focus on polymer composites. So as I was telling you, we have specializations. So we have expertise in MMCs, we have people working on polymer composites, but there is a scope, there is a focus of integrating this MMCs with polymers or polymer matrix composites with metal reinforcements. So there are 2 options. So this acts as a bridge. So this is most genuine and this is most required in the need of our for aeronautical engineering, and it reflects the emerging trends as I was telling you. So now we have done research on metal matrix composites, we have done research on polymer matrix, but it has the strength of both metal and polymer. So it has the applications of metal matrix composite materials as well as polymer matrix composite materials. So it reflects the current emerging trend of combining these two matrices to leverage the strength of both. And it should be a perfect uh, topic for an aeronautical audience, as aeronautical systems increasingly require multifunctional, lightweight, and thermal stable materials. So, if you look into the applications of aeronautical or aerospace systems, so they are nowadays multifunctional, and we require more and more lightweight systems. And also, the one of the most important parameter is thermal stability. So we use some aerospace systems in deep in space where thermal stability is one of the factors that we have to consider. And when we talk about the metal matrix composite material as a separate entity, and when we talk about the polymer matrix composite as a separate entity, most of us are not giving much concentration on this thermal stability problems. So as a whole, as an aeronautical engineer, it is a necessary for us, that is for when you're working in a domain like an aeronautical engineering which deals with space and other aircraft systems, you should be aware of all these multifunctional aspects, lightweight content, and thermal stable conditions. So these three important points makes us to realize that this topic is a very functional, it's a very essential topic for me. So now let us see into the session objectives. So in this session, what are the objectives we are going to see? So first, we will be understanding about the fundamentals of hybrid composite combining metal and polymer matrices. So either it will be a metal matrix with the polymer reinforcements, or it will be a polymer matrix with metal reinforcements. And next is exploring the fabrication type or the fabrication technique that is used, and also the properties and the challenges that we face when we are going into the fabrication and property testing of such material or such systems. And finally, highlight of aerospace applications and future research trends, what we are going to do when we find out all the properties, overcome the challenges that we are facing. So we are going to highlight what are the applications and the future trends for this metal polymer hybrid composites. So first, let us start with the basic introduction of hybrid composites, that is metal polymer hybrid composites. So by definition, it is a fusion of metal matrix and polymer matrix components. So as I was telling you in the start, either we can fuse a matrix with a polymer reinforcement, that is metal matrix with a polymer reinforcement, or we can include a metal powder in a polymer matrix. So it works in both ways. So that is why I have given the uh, the statement as fusion of metal matrix and polymer matrix components. And the trend alert, what we have to see is it is in modern aerospace designs. Increasingly, the integration of polymer and metal hybrids are used to optimize the mechanical, thermal, and failure behavior. So, as we all know, the development day by day, the aerospace designs are increasing. The developments are reaching to new levels, and the process of including a material for those applications is quite complementary. So, we cannot go with available monolithic materials, which has limited advantages on these applications. So what we can do is we have to integrate this metal as well as polymer, because we can use the characteristics of polymer as well as metal, so that it's a it's a very rare combination. And also both the properties of polymer and metal can be used to overcome all these problems that we face as a failure. So as a mechanical failure or a thermal failure, or generally a failure that is dynamic failure conditions like fatigue or anything, we can come across this. And sorry, and why we are using this combination. So why this combination is needed? So as we are talking about the synergy of mechanical strength, corrosion, and weight efficiency. So if you look into this characteristic, so when you look into the metal matrix composites, those metal matrix composites which possess aluminum as most of the matrices will be having a good mechanical strength compared with the normal metal. And talking about the corrosion resistance, so when we add the reinforcements, either it is a ceramic particle reinforcement or any other polymers that we are adding to this, they will improve the corrosion resistance. So the corrosion resistance is one of the major factor of materials that we use in aerospace application. So when a material is being subjected to an aerospace environment, that is an aeronautical, when it is being induced in some altitude, more than 30,000 or 40,000 feet, or in outer space systems, so it normally react with atmospheric conditions, and also due to some other issues also it will have corrosion. So we have to overcome these corrosions, and this is a better outcome for overcoming the corrosion resistance. And also, as we all know, composites. So when we talk about the composite materials, when we come across the advantages of composite materials, we see the first main advantage we all know is the weight efficiency. So the weight reduction can be done, and for that weight reduction, a bigger amount of strength can be given, and that gives us a better strength to weight ratio. So that is why we are combining this metal and polymer together. So how it is relevant to aerospace engineering? So in what way we are going to see this in aerospace engineering? So when we talk about the current challenges that the materials are facing in aircraft or spacecrafts, so not only in aircrafts we are using materials, we need highly performing materials in spacecrafts also. So when we talk about the challenges, we have this following challenges like thermal stresses. So not only normal stress, which is created due to application of load, is acting, but a thermal stress, a heat stress, is also acting on the spacecraft or aircrafts. So the temperature changes on the environment will act as a stress, will act in the form of stress, and they are termed as thermal stresses, which is very dangerous for the material to sustain. Why? Because the material may fail easily than a normal stress is acting. So when normal stress is acting, it may take some cycles of failure, but when thermal stress is acting on it, it makes the material to fail sooner, before that cycles to failure. So this kind of stresses will be leading to the creep failure condition. So we all know what is creep. Creep is a form of failure which induces thermal temperature as well as stress. So when the temperature is beyond 40% of the material's melting point, uh, creep is experienced, and along with the temperature, when stress is acting, the creep material fails due to the condition called as creep. And next one is fatigue. Fatigue is one such of dynamic failure condition where the material is subjected to minimum loads with number of cycles. So we measure this number of cycles in the scale of 10 power 3 to 10 power 9 cycles. And when the load is being applied and when it is being reduced, when the number of cycles increases, the amount of stress decreases, and because of the continuous loading factor, the material will fail. So this is a dynamic kind of failure. So it is relevant to time period. So it is related to time period, and the failure is very much common in aircraft industries. So if you look into any of the material failures, if you're looking in the maintenance MRO sections and all, so most of the failures happen due to fatigue failure. So 90% of the components in aircraft industries fail due to fatigue failure. And the next point we have to see is the weight reduction. So we need a particular amount of weight to be reduced in the aircraft and spacecraft, because when we reduce the weight, we can able to improve the fuel efficiency or the fuel economy of the spacecraft or aircraft. So this is one of the reason that we always look into we always look as a challenge for the materials that are used in spacecraft or aircraft industries. And multifunctionality. So the material what I'm using should have more function. It should sustain stress. It should sustain wear. So wear is one of the problem tribological factors. So it should overcome the other dynamic failure conditions, everything. So multifunctionality has to be possessed by the material in order to sustain, to gain a long life. So the application of the material should be happening for a long life, where the replacement could be avoided at the early stages. So where hybrid composites fits, so where it fits for us, so it fits in the high temperature zone. So we can use this metal matrix composites in high temperature zones. So in case if you want to see about the matrix, we can look into the different types of matrix that we have: aluminum matrix, aluminum and its alloy, and also we use magnesium and its alloy. So based on the temperatures conditions, the temperature values, our metal matrix can be used, and also we can vary them. We can use aluminum or magnesium, and also it is very flexible, and the impact resistant zones are available in polymer matrix. So if you look into the polymer matrix, the advantage of polymer matrix, the one of the advantage is to resist the impact forces, and also it is very flexible to use. Flexible in the sense it can be easily fabricated. The fabrication technique compared with the metal matrix composite material is far simple and easier. So we can do some hand layup or vacuum bag, or filament windings, so which is very simple when compared to metal matrix. As of if you go to metal matrix, you have to go with stir casting method, liquid filtration method, then powder metallurgy, which is little bit costly, as well as it requires some skill labors also. But whereas for polymer matrix, the inclusion of skill labor is very less for fabrication. And certain examples of this system where we can see as a fit is satellite panels. So nowadays, the satellites which are being developed carries lightweight, and they have many adaptation of multifunctional materials, and it is not regular materials that what we are using in our day-to-day activities. And they are very much into the deep material development state, like a hybrid material like metal and polymer composite materials, so that they can function efficiently and for a long period of time. Then comes the UAV frames. So nowadays we are using UAVs for all our applications. So major applications, what we do is surveillance. We are using it for attack. We are using for agriculture. So we are using agriculture UAVs, etc. So all these things we cannot fabricate, and the main problem of UAVs is they rely on batteries. So that battery system is very the time duration for the battery system is very limited. And when you're using general materials which is very heavy or little bit heavy than the normal composite materials, what it does, no, the thrust produced will be, the power generated by the battery will be sufficient enough to produce thrust for only few hours. But in case if the frames are very lighter, the thrust efficiency will be more for the concerned battery output. So it is better that we can implement this kind of materials in UAV frames. And finally, it is on engine mounts, where we use some jet engines. So also the covering, we cannot use it inside the engine. So the coverings, the mounts, where we can use the hybrid composites. So these are certain example systems that we are going to concentrate here. So first, once we talk about the introduction and relevance to composite materials, of where and when it is being used, so we come to the materials and design considerations. So what are the common metal matrices that we look into? So the first thing is aluminum, titanium, magnesium, and nickel alloys. So mostly we use alloys of all these materials for metal matrices. Whereas for polymers, we use epoxy, PEEK, and PEEK. And when it comes to reinforcements, so I was telling you about the reinforcements. For example, in case if you are using this polymer, that is epoxy, in as a matrix, you can add these reinforcements, like ceramic reinforce. These are called as ceramic reinforcements, which are silicon carbide, boron carbide, carbon fibers, and carbon nanotubes. You can use these reinforcements in metal matrices as well as in polymer matrices. And also you can use some powders, steel powders, for the polymer matrix as a reinforcement. And these materials are to be considered while you are fabricating or while you are designing a composite material, that is a hybrid composite material. And the critical interface issues what we face when we do this is thermal expansion mismatch. So when we talk about the properties, one such property is about bringing the thermal properties like thermal conductivity of the material and thermal expansion. And if you look into the metal, polymer, and reinforcements that we use here, the thermal expansion values are different for each type of material. For example, metals will be having some thermal expansion value around some 12 or some 20, etc. But for polymer, it will be less than that. And for reinforcements also, it will be between the polymers and metal matrices. So it will be having some variations. So when the thermal expansion is mismatching, and we cannot properly use them under thermal problems. So the reaction of the materials, different reinforcements or matrices, whatever we are using, based on the heat or the temperature applications, they react differently. And this is one of the critical interface issues that we are facing nowadays. So for that, what we have to do, so we have to come up with certain condition that the thermal expansion of the matrices of the reinforcement is slightly matching. Not there should not be much deviation there, or there should not be much variation in their thermal expansion properties or thermal expansion values. And delamination risk, so this is one of the failure that we face in composite materials, delamination. So the layer of the material is being delaminated, it goes as a whole and it is being removed. So this is a very much major concern in the composite material failure, delamination. So this should not happen. So this, because of mixing of two different materials of two different properties of two different densities, this lamination will happen. If you look into the failure of metals or metal alloys, for example, if you look into the carbon steel, the failure, there is no such delaminations will happen. So this delaminations, how to study this, it is the best way is to study the tribological properties. So when you do dry sliding wear test, you can able to understand the delamination failure. And if you do a dry sliding wear test for a mild steel or a low carbon steel, we can see that delamination is very less. The delamination failure on the surface of the material will be very less. But whereas if you do the testing, same testing for a composite material, which is a metal matrix composite or a polymer matrix, we can see that the layer will be one of uh, more when compared with the normal alloys. This is because there is a mixture of two materials which is having two different densities, two different properties, and always there will be some wettability problem. So this wettability problem we can able to reduce it, but we cannot completely eliminate it or we cannot completely eradicate it. So that is the problem of delamination that happens in composite materials. And surface treatments for bonding. So as we know that surface treatments, heat treatments are done for improving the efficiency of the material, because they improve the bonding between the two elements. And this surface treatments is not much possible in polymer matrix composites. We can do surface treatment or heat treatment in metal matrix composites, and that too we have some limitations for it. We cannot completely do, we cannot go beyond certain region of temperatures as we go for heat treatment process in steel alloys. Even for aluminum we have two kind of heat treatment process, which is solution heat treatment and precipitation heat treatment. Whereas we for iron materials or iron based materials, ferrous based materials, we have more heat treatment process. So what happens when heat treatment or the surface treatment happens, they bond the material together. If it is a alloy of same, for example aluminum alloy or steel alloy, they will make the material the material to bond each other in a very good and efficient way. But whereas in composites, it is too risky and it is not happening much. So considering about the design, the materials that we use in composites, I would like to show you a paper, recent paper, recent in the sense it was published in 2021. So properties of metal polymer composite materials with aluminum and magnesium matrices. So this is a Russian paper where you can see there is a porous material, and there is a porous material which is a metal matrix. That is, the matrix is metal here, and it is porous. It is having holes, and it is being filled with polymers. So this makes a metal polymer composite materials, and this is made by aluminum A7 alloy A7 and magnesium Mg90, and it is called as open and interconnected porosity. So the process of making material porous is called as open and interconnected porosity. So these are defined porosity, and there is a procedure for this, and you can see the author has made samples. So first he has fabricated the aluminum and magnesium matrices. Then he has injected with polymers, and those polymer materials, that is hybrid metal and polymer materials, are tested. So they have done UTM testing and bend test, 3-point bending test, and also they have done some testing on compressive strength. So these are the, so on the left side you can see the compressive strength, and on the right you can see the sliding friction. So for tribology also they have done the fabricated, they have created the specimen, and you could see what is the properties of porous metal and metal polymer composite materials. They have given a comparison values for density and for compressive stress, and for ultimate tensile strength and ultimate bending strength. So we can see that for porous aluminum, there is some improvement from porous aluminum. So you can see this from porous aluminum, the density was 1.20. So even the density has improved. We can see that that compressive strength, the ultimate tensile strength, as well as the ultimate bending strength of porous aluminum is less when compared with the metal polymer based composite on porous aluminum. So it has improved, and you can see the improvement has been carried out. So around some 54, from 18 to 15.4, it has been done, and it is around some 33 percentage increase has been studied in compressive strength. But in case of tensile strength, we can see that it is around some 64 percentage improvement, and whereas in case of bending strength, we can see the improvement is around some 75 percentage. So there is an improvement in the properties when we use a combination of metal and polymer. So in both aluminum as well as magnesium, they have tried this, and the only drawback that we can see is the density is increasing. So it is not a harm that the density is increasing. Even if we calculate what is the density increase, it is around some 7 to 8 percentage. That's all. So if you look into the conclusion, and also they have done this wear test. So this is the wear test they have carried out, and you can see the conclusion saying that the material produced by the method suggests possess higher compressive and bending strength than the strength of components of the composite at an inconsiderable elevated density. And you can see also understand that the metal polymer composites have low coefficients of sliding frictions. So this will be very much useful for tribological applications. If the coefficient of friction is very less, and we do sliding friction analysis, so the coefficient of friction is very low. And also you can see that they have understood that the thermal conductivity of the material is high, as well as the wear resistance is also high. And they have given a statement that this is very promising material for production of sliding bearings, and we can also use this in satellite applications. So if you look into the major concern about satellite applications, nowadays, even last year during respond project, ISRO has come up with some problems in composite materials where they want self lubricating ceramic matrix composite material, which should be having both polymer as well as both matrix and reinforcement with ceramics. But in case of fabricating a ceramic matrix composite material, it is little bit quite complicated, as well as it is a kind of costly process when compared with the fabrication of metal polymer hybrid composite material. So instead of going with ceramic matrix composites, we can try out this type of materials, and still only limited resources has been found out in this kind of study. So when you talk about the ceramic matrix composite material for high temperature applications, they are not very suitable. Even though they are ceramics, they have some cracks internally developed, and those cracks will be trapping the heats which are generated, and because of that hotspots will be created, and these hotspots will be a hub kind of place where the thermal stress will be acting. So ceramic matrix composites is having certain disadvantages which can be overcome by using this metal and polymer hybrid composite materials. So now let us see into the processing and manufacturing technique. So the co-processing approaches is powder metallurgy and polymer infusion. So powder metallurgy and polymer infusion. So first we can fabricate the metal matrix composite using powder metallurgy technique, and we can infuse the polymer in it, which will be easy for us. And next one is frictional stir welding or frictional stir processing. So when we use frictional stir welding condition or processing condition to fabricate a metal matrix composite, then we can use the same with ceramic matrix composites also. And the last one is the most recent one, 3D printing or additive manufacturing of multi-layer systems. So we can load the 3D printer with metal as well as polymer, where layer by layer we can have different multi-layers with different size, different thickness, and different combinations. For example, layer 1, layer 2 can be metal, layer 3, 4 can be polymers, and the orientations of the polymers can be also changed. So this is one of the advantage, but there is no much um, research activity that is been going on in this area. So only few people have tried and they have come up with some solution. But as far as my knowledge, I would say that instead of frictional stir welding or frictional stir processing, powder metallurgy and polymer infusion and 3D printing or additive manufacturing will be best suited manufacturing technique for this condition. And we can also use joining techniques like we do for normal welding techniques, which is one of considered as the one of the joining techniques. So we can go with adhesive bondings, mechanical interlocking systems, and hybrid additive subtractive process. So these are certain joining techniques that we can have a try over this processing technique. And let us see about the mechanical and functional performances. So the thermal stability from the MMC components. So generally, when we talk about metal matrix composite material, many have not carried out research in analyzing the thermal properties of metal matrix composite material. Normally, if you look into any of the research papers, the people will be doing the analysis on mechanical testing, tribology, and microstructure level. They will do the study, and certain people would have gone for thermal studies, and certain people would have gone for heat treatment process, where the same ultimate tensile strength or hardness would have been improved. But if you look into the thermal analysis of metal matrix composite material, there are very limited papers, and in those limited papers, they have given a condition that the thermal stability of metal matrix composite material is far better than a normal monolithic metal. So because of the reinforcements. So when we talk about the reinforcements, which I showed in the previous slide, which is silicon carbide or carbon nanotubes, they possess very high melting temperatures or high performance temperatures. So because they are considered ultra high temperature performing materials, so they perform in a very efficient manner in high temperature applications. Normally, as a separate entity, we are using them for high temperature applications. We use them in coatings for powder coating, metal for polymer ceramic coating in rocket engines. The inner lines of rocket nozzles, we use ceramic coatings to avoid the material's direct contact with the high temperature that is produced. Even in combustion, jet combustion engines chambers, that is jet engines combustion chamber, we are using that. They are very good highly temperature resistance, and when they are added with this metal matrix composite material, I mean metals, which forms metal matrix composite material, the thermal stability of the material improves much. But there is very limited application, and there is very analysis, very limited analysis that has been done, right? So talking about the next properties of polymer matrices, toughness and damping. So toughness and damping from polymer matrices is one of the property that we can inherit it for this composite material. So this materials polymer matrices possess toughness is there, damping is there. So vibrational damping can be uh, made, and these are certain properties that we inherited from polymer matrices, and this will be also been an advantage for the hybrid polymer and metal. Polymer and metal hybrid composite materials, and also lightweight with targeted stiffness zones. So we have to come up. So in the previous paper which I showed you, the density would have improved. I mean, would have increased. Because of that, the weight of the material would have increased. But there are certain ways. So there is another one paper where it shows that the author has used polymer matrix with metal powders. So in that case, the density, because the density of the composites mainly depend upon the matrices what we are using, because we are using the matrices to the major part, that is we are using near to 70 to 80 percentage. If we go to metal matrix composite materials, we are using up to 80 percentage to 90 percentage, we are using metal as a mattress. When you go to polymers, we go with the rule of mixtures, where we go with zero point 0.7 volume fraction or mass fraction, something like that, and it is around some 70 percentage. So only the density of the reinforcement is very less over there, right? So if you go into the density of the composite materials, so it depends mostly on the matrices what we use. So in the previous paper which I showed you, has metal as the major matrices, with polymer has been injected as a reinforcement. So in that, density has increased. But in case of another paper which I was telling you, where the reinforcements are added, that is metal powders are added as reinforcements, and the polymer acts as a matrix. So in that, the material will be having less density, where it can be used as a lightweight material for certain targeted stiffness zones. So the lightweight materials are needed for certain regions, and so in certain regions where we need to have the strength of the material, we have to go with the metal matrix composite material. And the comparison with conventional composites, so the conventional composites, the regular composites that we have in nowadays, so it has more strength to weight ratio. So comparing with the conventional composite material that we use normally, these materials, that is hybrid polymer and composite materials, will be having high strength to weight ratios, and they are very good in fatigue resistance. So when we talk about the polymer matrix composite materials, they are not good at resisting fatigue. So they can able to do the damping conditions. They can able to give toughness, but the fatigue is one of the major problem in our aircraft industries, which we have to note. So in metal matrix composite material, they can able to sustain the fatigue failure, because they have possessed the major properties from the metal matrix, that is either aluminum or magnesium. And if you look into the SN curve, that is stress versus number of cycle uh, curve for aluminum or magnesium, which is non-ferrous materials, they don't have much endurance limit. They have only fatigue strength. So when a material is possessing endurance strength, that is endurance limit, then the material, that is ferrous, mostly ferrous materials, as well as titanium alloys. So titanium alloy is one of the material which is not comes under the category of non ferrous material having endurance limit. So this ferrous and titanium alloys possess endurance limit, which is very much favorable for fatigue applications, failure resistance. But whereas aluminium, to a somewhat level, we can use aluminium and magnesium. But when we go with this combination of metal matrix and polymer, that is metal polymer hybrid composite materials, fatigue resistance is one of the wonderful property that we can obtain from this. And finally, thermal conductivity. As I was telling you, thermal properties is not been analyzed much, and one such property that we have to give importance is thermal properties, where we have to study about the thermal conductivity and the thermal expansion of the material. So comparing with the conventional composite materials, that is either a separate metal matrix composite material or a separate polymer matrix composite material, these three properties have major advantage when we use this multifunctional hybrid metal polymer composite materials. So let us see into some of the case studies or industrial applications about these materials. So in jet engine casing, we are using hybrid composites with the internal metal matrix structure and external polymer shell. So the internal hub casing will be having metal matrix structure, and it will be possessing metal matrix composites, and externally it will be having polymer shell. A polymer layer will be there. And the second one is space satellite panels. So the high thermal gradient zones handled by hybrid composite materials is one of the major concern in space satellite. So when you look into the space satellite panels, they are functioning at outer space at high temperatures. So the temperature at outer space, because the direct sunlight is being absorbed by the satellite panels. So because of that, they might, if we are using some normal materials which is not having that much high temperature improved properties, we might be having a problem. So this problem can be overcome by using this hybrid metal polymer composites material. So in places where high thermal gradient problems are there, those applications can be handled by this hybrid composites. And finally, UAV components. So they are lightweight, yet we need some damage tolerant frames. So we need lightweight, but if you go for any polymer, a plastic material for frame, when it is falling down, when a UAV component or a drone component or a drone is flying and it is being hit by some buildings, or when it is falling down, there will be damages happening. So when we use this hybrid metal polymer composite materials, we can able to produce a lightweight material, but also we can get some damage tolerance frames. So these are the case studies which we can give a try, or the research concerns we can look into. And also in industrial applications, these are much needed nowadays. And finally, emerging defense and automotive cross sector uses, sorry, that is actually uses. So nowadays, when defense technologies, we have a lot of developments that is being taking place. So in our institution we have this defense technology. So in this defense technology, we teach a subject called as warfare simulations, and we teach about rockets and missiles. So in this crossover, when we talk about the materials that we use in defense technology, we have to use advanced materials in order to make the system function efficiently. So when we use this kind of hybrid polymer metal composites, they will be quite uh, useful for us, and they will be quite efficient for our applications. So modeling and simulation. So we can do finite element modeling of hybrid structures. We can do stress strain analysis using Abacus or ANSYS. And also we can do thermal cycling and fatigue simulations in this. So when we fabricate a material, so what we do, we generally do the material testing. So before doing a material testing, we can try the finite element modeling of these hybrid structures for these two conditions. So we can try for stress strain analysis, and also we can try for thermal cycling conditions as well as fatigue simulations we can do. and predicting interface failure and delamination. So when we talk about the failure of the material, so it comes as an interface failure and delamination. So the simulations can be done. So how far the delamination, how far the tribological issues will happen on this material, how it will delaminate the material, how the interface will fail, how the bonding breaks. So these can be predicted using modeling and simulations. And finally, we can go with smart design with digital twin models. So nowadays we are moving into advanced technologies. We are moving into this digital twin models. So this digital twin models, that is like we can simulate a condition of high altitude, or for example an engine is performing at certain altitude. And the experimental data can be obtained from the engine, and a model here in the ground station can be created using a simulation software, and we can change the conditions. And if any other condition changes in the actual working engine, what will be the effect of those changes here? So that can be studied from the ground station. So that is what digital twin. So we are twinning the technology through a digital method, and from the existing issue. So for this smart design, smart material design, we can use these materials. So, what are the research trends and future scope for this topic? Because when I was asked to deliver a content on your FDP, so I was thinking on what we can do. So I thought of integrating metal matrix. So, is there any options where we use both metal matrix, composite material, and polymer matrix, or metal and polymer in anywhere? So I came across this two research papers, very beautiful research papers, even though the publication house might not be a good one, or somewhat to some Q3 or Q4 level. The amount of work or the knowledge what they are telling us is very good. So we have to see what are the possible ways that we can do research on this. So functionally graded materials. So for particular functions, we have to tailor our materials, its applications, everything. So that is functionally graded materials. And nano reinforced hybrid composites. So here we can use some nanoparticles, nano metal powders, nano polymers for making this hybrid composite materials. So we can give a try in that. And we can also go with some artificial intelligence, machine learning based composite design and failure prediction. So it is not needed that you have to fabricate a material. By knowing a property of this type of material, you can change the model, you can change the orientation, you can change certain parameters, and using a AI and ML model, you can predict the design, and you can also predict the failure. And also nowadays we are moving into sustainability conditions in aerospace applications. So one such sustainability is using green materials. So this can be seen as a green material, as a alternate way of using regular materials. We can go with some recyclability. So we can grow with some aerospace grade hybrids, which can be acting as a sustainability and recyclability materials for our applications. So these four terms can be tried out in the future scopes, or as a research trend we can try these four topics. And that's all from my end. And there is lot of certain papers which are available. I can show you some of them. So they are, in certain papers they are they have done actually, they have used additive manufacturing, and still it is under review phase only. So uh, we have to get into it, we have to see. And you can see this paper has a method called fusion deposition modeling, and using process parameters. So this is like you're investigating the properties of metal polymer composites, which is fabricated by this technique. And next is metal-alike polymer composites. So they are using some pseudo ductile behavior. they are studying the soda means two-way ductile behavior of carbon fiber and epoxy resin material, and also multifunctional liquid metal polymers. This is one of the thesis which I got to know, which is recently published. And metal polymer composites and their characterization, and this one which I showed you, and multifunctional properties of metal fibers, reinforced polymers, composites, a review. So there are recently many people are trying into this hybrid metal polymer composites. So we can also have a look into it. So we can also have a look. We can also go with some journals. So there are limited journals. We can try to get more journals. We can start working on that, so that this is a kind of future trend that we are going to develop now in the upcoming days. So now the floor is open for any questions or challenges or collaborations possibilities. Anybody is welcome.
Yes, participants, if any queries for Dr. Kousik Kumar sir, you can. Anyone?
So possibly this might be a kind of new topic to you, and since the resources are very limited, the constraint of putting more informations is also there. And whatever I gone through all these three papers, I've just given as outline here. So if you need, you can have a contact. You can contact me regarding this, and also even I'm also trying to explore more on this hybrid composites.
Yeah, yeah, very limited work has been done on this
Yes, sir.
type.
Actually, if you look into the satellite applications, sir, so now
Hmm.
the major application of these materials are into satellite panels only.
Yeah, yeah.
And if you look into the ISRO's respond basket, which is being released every year during December, and the application ends by January. If you look into that problem statements, they will be giving some satellite related. So the amount of materials will be very less. It is not like normal materials what we use. So
Yeah,
they have
yeah.
some specific materials, and they go with different materials like this. So recently, I had one opportunity to apply there for ceramic matrix composites.
Oh.
So this is an ongoing topic, and
Yeah, because
in the next 5 years, we may expect more papers if we start working now itself.
as you mentioned, no, because of that coefficient of thermal expansion is different for this, and for the metals it is actually around two for steel and all 12 something 10 power minus 6. But whereas actually for polymers actually it is very low, so they can expand more. So because of
Yes.
that mismatch, actually many times actually issues are there, because one molecule is able to take more stress, other one is not able to. So you have to balance between them.
Yeah.
Hi, sir. Good evening, sir.
Yes. Good evening.
This is Vijayan from Satyabama University. Actually,
Yeah.
I did my PhD in hybrid composite, sandwich composite, sir.
Okay.
But I faced difficulty in numerical analysis, even modeling itself, ANSYS or abacus. And that time,
Hmm.
the modeling is difficult for different material sandwiching. So I am in need of this area. Can we any easy modeling softwares are available, sir?
So I would tell you a recent mail which I have received. There is one company here in Bangalore.
Okay, sir.
They have developed some software related to modeling of composite materials.
Okay, okay.
And they have sent me a mail, and they have told me to go through it and try. I'm also not sure because of my other academic occupancies, my workload. I was not able to check that. So probably we'll have a discussion. So you
Sure,
can
sure,
contact me, and like I'll show you my QR code. So this is my contact information. So if you scan this, you will be getting my website. My uh, number is there. Appointment form is there.
okay,
You
sure,
can
sure,
contact me, and we will have a word with that.
sure, sir, sure. Actually, I struggled for two to
Nowadays,
three years
when we
regarding
talk
this.
about the modeling of composite materials, so this abacus and all, it is a little bit quite complicated. Even one of my friend who is doing his PhD in NITTE Suratkal, that is National Institute of Technology Suratkal, here
Yeah,
near
yes,
the
sir.
Bangalore. So he has an issue of fabricating multi-cell composite materials.
Oh,
So
sure.
we are working on that. I'm just helping him out regarding the numerical simulations, because numerical simulations of composite materials is quite difficult in normal
Yeah, actually,
simulation.
pure GFRP or composite are very easier. When we go for hybrid metal with
When you go for hybrid,
GFRP,
when you go for any orientation change, for example,
ah,
he's using he wants bidirectional lamina, but
oh,
in the abacus it is unidirectional lamina is only available.
yes, sir.
So
Bowen
he has
drawing
to
matrix.
change the subscript of unidirectional to bidirectional, which is quite complicated. Nobody knows it.
Yes, sir. In modeling itself, I feel difficulty in
Yeah,
that.
that is a problem. And as I told those people, they developed a software. They told like we developed a software where you could do the entire modeling, and then you can import that to any of the analysis tool, and you can do the analysis. And I'm just keeping it on hold because I was not able to look into it, because we need some time to look into it.
Yes,
And
sir.
our academic schedule just got over by last week, and we are going to start our next period of exams vacations. So I'll be working on that in the upcoming days. So if you want, you can contact me, we can have a discussion, we will go through it.
Sure, sir. Okay, sure. Thank you.
Thank you.
Any others? Any queries? Yeah, Madam Kameshwari Devi saying thank you, sir. Okay. Dear participants, any other queries to Kousik Kumar sir? Actually, because as he is in Bangalore, that is a place where actually many things are happening on aerospace. So I think like Dr. Bijayan sir actually interacted, others also can take the advantage of the things.
Yes, we have many industries working on materials here, and,
Mm, yeah, 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 yeah.
and also many aeronautical, aerospace related, drone related companies in Bangalore.
Mm, yes.
And we are sending many of our students for internship there, and they work on composites. Even we are sending our students for IIT Madras for doing internship. So
Mm,
recently, I have a discussion with our IIT professor from Madras, that is ITM. So we were discussing about the possible materials that we can develop using powder metallurgy, and we are in idea of developing this material also. So this will be happening in the future, and I hope these materials will be having much more advantages than normal metal matrix or polymer matrix composites. So these two citations I just like to show, because these two are the major papers that I verified while preparing this PPT. And as I told earlier, there is very limited resources, and with those limited resources we can it is not that we cannot try, we can do something, and keeping these things as a base work, and we can start some ideologies are there, and we can do. So you can scan this QR code, it will be leading you to my website. uh, my contact details are there, and also you can look into my publications and other details, you can check it. And if you have anything, you are open to approach me, I can help you out.
Okay, thank you. I don't think any other is having anything. So anybody needs, sir, you just scan it so that actually you can have a contact with sir. So thank you so much, Dr. Kousik Kumar, sir, for your valuable inputs on hybrid metal polymer matrix composites. Although many actually talk happen only on polymer composites, so really it's an eye opener for many of the people, those who are working on research as well as ready to apply for some funded projects and all. Actually, it will be helpful for them.